This is your go video for section 2.2. If you had any questions with the go problems, hopefully this will clear it up. So let's take a look. I snipped it right out of your worksheet. And what we're going to do is we're going to use this table that they give us to identify the vertex. Remember what the vertex is. The vertex is that point on a parabola. If it looks like this, you have the option of it looking like this, or maybe it even looks like this. Okay, that point where something important happens, it's where the fold line is located, and it's where we go from, in this case, if we are reading it left to right, we are decreasing, and then all of a sudden we start to increase. So it's a breaking point of our graph. Here we're increasing, then we're decreasing. This is where that vertex is. It also happens to be a minimum or maximum point depending on the graph. In this case, this is the bare minimum this graph will ever be. It's the bottoming out of this graph. And in this parabola, it is the maximum point. And it also is the point where our graph symmetry passes through. This is the fold line. Our axis of symmetry is right here. It's a special line. It's an x equals a number line, and it's x equals whatever that point is on the vertex. The vertex is at x, y. So it's the x equals value on the vertex. Okay? Now, so that's the vertex, and the axis of symmetry we talked about. It's going right through that vertex at the x equals point. And they want to know the number of x-intercepts. X-intercepts, it's our x-axis, that's our y-axis, are where it crosses the x-axis. And in both of the examples I'm giving you, there are two x-intercepts. It touches it twice, but that's not the case always. You can have parabolas, maybe it's a smiling parabola that is up here in quadrant 1. It will never ever touch. So there's possibilities where it will never touch, and there's possibilities where it could touch just one single time if the vertex happens to be directly on that x-axis. So these are the things we're going to be looking for, but we're not going to be given the graphs, we're going to be given tables. So what we need to determine is how can we find a vertex by looking at the table. So you have options. Yes, you could hand graph every single one of these and you will figure it out. And if that was your only option of figuring it out, then do it that way, and I applaud you for getting the right answer. But if we look, there is symmetry, so there should be something that shows up as some sort of pattern. Now we know it's a function, and functions cannot have anything repeat for the x value. That's why these just go straight in order, because every single time I plug -4 into this equation, I should get 10 out. So -4 always goes with 10, so -4 will never repeat. But if you look at the y coordinates, something will happen here. 10, 3, -2, -5, -6, -5. I've seen this before, -2. Right here at this point, 0, 6, something happens. Our numbers are changing, and all of a sudden I'm reverting back to numbers I've already seen. This point is the vertex. The vertex is where we start seeing the repeat of numbers. Because after you get to this point, then you start doing what you did before. See, they all match up here. Okay, so our vertex is 0, -6, and you can tell because of those repeating values. So I have 0, -6. Now let's go ahead and put a little graph here and just graph the vertex only, 0 down 6. So it's right here. Okay, -1, -5 is here, 1, -5 is here. I have a parabola that is opening up. That axis of symmetry we know goes right through the vertex. So that is going to be x equals whatever x equaled in our vertex, so that's x equals 0. How many x-intercepts is it going to have? Your choices are here 0, 1, or 2. How many x-intercepts are there going to be? There's going to be 2. It's going to touch it twice. And they also want to know, is this point a maximum or a minimum? The point is a minimum. Okay? So let's look at 25 and see if we can see that repeating happening. Let's see, 49, 28, 34, 1, 4. Oh, here's the repeat. So what is the middle point of that? There we go. The repeating's happening here. So that vertex is 2, 1. The axis of symmetry goes through the x-coordinate of the vertex, so that's x equals 2. How many x-intercepts is there going to be? This is harder for kids to see, so I do encourage you to go ahead and draw a quick graph of the vertex, 2, 1, and just 1 point on either side of it, 1, 4, oops, and 3, 4. So we have a smiling parabola again, opening up. How many times is it going to touch that x-axis? It's not. There's going to be 0 x-intercepts in this, and that's okay. Maximum or minimum, what is this point? Is that the top or the bottom? It is the minimum point. You could have circled, I guess, if you wanted to. Okay, question 26, looking for the bouncing, -9, 3, 7, 3. There it is. That's when we start seeing the pattern repeat. So guys, we could continue this. So what is -8 going to be? Well, -8, what's after the -9? It's going to go with the -29. You could fold that table right at that vertex, and those numbers are going to match up. But anyway, the vertex is at point -5, 7. Axis of symmetry goes through that x-coordinate. So that's x equals -5 in this example. Quick sketch, where is -5, 7? It's up here in quadrant 2. Remember how the quadrants are labeled. Quadrant 1, and we use Roman numerals, is positive, positive. Then we go counterclockwise around. So the vertex is in quadrant 2. Either side, -6, 3. So this time we're going down. -4, 3. Okay. So how many times is that going to touch the x-axis? So we got 1 here and 1 here. That's 2 times. And since it's a frowning parabola or opening down, this time we do not have a minimum, but we have a maximum. Finishing it up, 27. Right away we can see where that repeat happens. If you're not careful, you can miss that one because they only show you one chance of the repeating number. So our vertex is -7, -8. That's going to be in what quadrant? Negative, negative quadrants. Down here in quadrant 3, -8, -9 is going to be further down. Okay, not much of a picture here. Okay, the axis of symmetry is x equals -7. It's not going to have an x-intercept because it's going to be way down here in quadrant 3, and it will spill into quadrant 4 there, but that's going to be a maximum value because it's opening down. That's your Go video for section 2.2. I hope it cleared up any questions.